Okay, I think we're all set. All set here. Excellent connection. Tremendous connection. Okay. So this one's for helping some friends out, right? First things first, we'll get the cabin lights on. And the attitude indicator light on. Just to help out with seeing things in the capsule here. Right. So I like to start off with learning spacecraft by just knowing what everything is called early. I noticed that some people confuse the names of things, and I'm one to believe that learning a spacecraft is really almost as simple as learning the name of something. When you learn the name of something, it becomes very easy to know what it does. You may not know how it works, but at least you know what it does, which is a hell of a start. So all this top stuff, we know it's radio. We've got a coax controller, like a coaxial cable, yeah. Audio and UHF transmit receive, UHF relay, tone voice operated transmission. You've got TV, HF transmit and receive. So transmit and receive, right? Transmit and receiver. Oftentimes we'll just shorten that to transceiver, right? That just makes things much easier to say, right? So we've got audio and ultra high frequency transceiver and high frequency transceiver, antenna controls, and we've got our whip antennas for high frequency, ultra high frequency, and this says diplex. That's actually a typo. It's supposed to say duplex. Yeah. Our electric timer. This is the mission timer here. And our event timer, that is the settable one here. Booster cutoff controls. Retro auto manual. This right here, TR256, time to retro, 256 seconds. TR256. This controls the countdown. This links the countdown from the computer on core 19 to the retro sequencing panel here. So if you're having a mission which is longer than the core 19 countdown, just go ahead and flip this breaker off. As a matter of fact, the checklist has it off by default. Environmental control system indicator lights. Indicator light test. This is the bus for it. Now we've got our sequencer lights, power and control. The sequencer lights are here. Power will allow the light to light up. Control will allow you to push the button and actuate whatever it is you need to do. Parachute control. Attitude indicator control for retro and landing. Boost insert control 1 and 2. Retro sequence control 1 and 2. Landing sequence control 1 and 2. Attitude indicator with flight director indication or without, let's see, they have the same switch on the other side, so without flight director indication. Okay, so setting up this first panel is quite simple after that. So here we have boost insert, retro for powering, so you can arm the power of the retro system and the jettison. Landing, and then your individual rockets, right? Squibs are these tiny explosive bolts that explode to sequence the rockets, yeah? All of these are squib systems, right? So the panel here, it's as simple as this. All right, make sure secondary O2 bottle is open, abort handles in normal, and the rest is just like this. And there you go. Now you can take attitude indicator with FDI, and our squibs are all going to be safe for the time being. Now let's cover this front panel here. So here we've got our pre-main 40,000 drogue and our main 10.6 thousand main chute. This is the emergency, what is that? Emergency main, yeah. Here we can see with desired platform and rate. So RDR is rendezvous radar, yeah. Middle is platform, and the right is computer. So platform, rate is how fast you're going. Attitude is where you're positioned, and mix is a mix between the two. So for launch, you're going to keep it on platform and rate with the scale set to high, which it already is. Here we have the abort light, longitudinal acceleration or G-forces. Here's your indication lights. So attitude rate is a light that will come up if something is going wrong in your launch, right? This light will light up if something is going wrong. Your attitude is off, you're moving too fast. This light will light up, and it's most likely, if you can't get it under control, going to trigger the abort light in a few seconds. Secondary guidance is a failure of the Titan II's primary guidance system, and you run on secondary. This is not really an abort situation, but it could turn into one. Then you've got your engine 1, 2, 1 and 1. So left and right engine, and then your stage 2 engine. Here's your stage 1 fuel and oxidizer, stage 2 fuel and oxidizer. This is the FDI, flight director indicator, right? So rather, this is your attitude indicator. With FDI is with these yellow needles, without is without the yellow needles. So the ball will still work, but the yellow needles will be unpowered. This is a clock. Here is your rate of descent, your barometric altimeter, propellant quantity. Right here is your IVI, inertial velocity indicator. We'll talk about this later. Your range rate, or the radar readout, as I like to call it, and your event timer. Coming over to the middle panel now, we've got our coolant pumps, primary and secondary, cryogenic quantity gauge, circuit breaker. This is the aux receiver. Here's your beacons, which in the future will be known as a transponder, but this is the beacons, yeah. DC to DC converter. This converts DC to DC. It's like a transformer, but a very, very cheap and small way of doing transforming of voltages, right? You can convert AC to DC with a converter. You can invert DC to AC with an inverter. But if you convert DC to DC, you step down the voltage. Just like if you invert AC to AC, you can step down the voltage. Suit fans. This is the clock light. Water heaters, primary O2 heaters, your standby matrices, or not matrices, sorry, standby transmitters. Yep, transmit, as you can see, X-mitters, transmitters. RT stands for real time. DT stands for delayed time. TM This is telemetry. O2 rate controller. Coolant valves. Evaporator heater. Orbital attitude and maneuvering system heaters. Lights. It's a DC-DC converter controller. RCS squib, reentry control system, not reaction control system. Reentry. It's a very important distinguishment. Propellant orbital attitude maneuvering system control. And the regulators. REG, regulator. Acme controls, attitude control and maneuvering electronics. Roll jets can either be coupled for pitch jets or yaw jets. You'll notice down here that there is no roll. There's just pitch and yaw. That's just changed with the switch. Acme bias power. Attitude control, maneuvering electronics biasing power. OM's reserve. Maneuvering thrusters that you know, attitude thrusters that you know, attitude drivers you know. Acme, logic, yep, we've covered that. RCS system A and B. Cabin recirc will vent CO2 from the Sooth loop. So you'll be pulling this and putting it back up every once in a while. Snorkel lets in fresh air. Cabin vent. Water seal for the pressure regulator, and the O2 high rate recock. This is essentially reset. Radiator flow bypass, evaporator heat, evaporator maximum flow or normal flow. Here is the primary cooling reservoir, and here is the secondary cooling reservoir. Cabin and suit temperature, cabin pressure and partial pressure of O2, CO2 that is. This is measured in millimeters of mercury. Millimeters of mercury. mmHg. Secondary O2 pressure. Here we've got O2 high rate light, RCS heater light, recorder tape light, environmental control system heaters light, fuel cell 1, delta pressure. This is not an A, this is delta, stands for the rate of change of pressure. Fuel cell 2, delta pressure. Here we've got jet fairing, separate spacecraft, indicates retro attitude. We'll talk about that later. Battery power, reentry control system, separate OM's line, separate electricals, separate adapter. The rest is pretty obvious. Cryogenic heaters, hydrogen vacuum tank. TDA, this is for the docking adapter. So T, I forget what that stands for, but it's docking adapter. Yes, T, target docking adapter control. Yeah, target docking adapter control. This controls how that would work. I suggest leaving this at all times. Here's your regulator for the OMs, propellant quantity, and RCS A and B, and the explosive system. Comms panel, so we've got the silence. We've got keying, which is the activation of the comm system. Is it voice-operated control, push-to-talk, or continuous intercom push-to-talk? So essentially, only the intercom or transmitting to mission control via push-to-talk or Vox. Record is control, and this is supposed to say pretty sure this is oh my god, what is this one? Pretty sure this is supposed to be NOM as in nominal. Beacon control, you've got your rescue beacon, your S-band beacon, and your C-band beacon. Calibrator, standby transmitter, real-time, delayed time, transmitter, real-time, and acquisition. Command, real-time, or sorry, this is not real-time and acquisition. This is receive and transmit and acquire. Command, control, receive and transmit, delayed time. TM stands for transmitter. Transmitter AC bus. Yep. Tape playback, antenna select. So when they say go to reentry C-band beacon, that's what you would do. HF antenna, extend, retract. This is the rendezvous radar. Here's your platform, cage, sharp and forward, orbit rate, blunt and forward, cage and free. This is the horizon scanner, right? Not the horizontal scanner, the horizon scanner. Rate gyros, yaw, pitch, roll, primary, secondary. Here is the computer. Pre-launch, ascent, catch-up, rendezvous, target, docking, preparation, and reentry. You normally are not going to use target docking preparation. Instead, you'll just use rendezvous. TD pre doesn't offer much helpful stuff. We'll talk about that later. Here we've got platform, reentry, rate command reentry, pulse, direct, rate command, and horizon scanner. Propellant motor valves, orbital attitude and maneuvering system, and reentry control system. Here is control power. Again, OMs, attitude control and maneuvering electronics, or direct control. Now let's cover this section over here. This is the aux tape controller. This is what stores computer programs. Auto, rewind, wind, program, and standby. None of these top switches are functional. This is the crossover. You can essentially tie section 1 and section 2. It's only used for doing purges. This is fuel cell section 1, fuel cell alpha, fuel cell bravo, fuel cell Charlie, fuel cell section 2, alpha, bravo, Charlie, right? So there are 2 fuel cells on board, but each fuel cell actually has 3 fuel cells in it. So that's something you have to keep in mind. A fuel cell is extremely tiny. It could fit in the palm of your hand, right? Some of these bigger ones for high power are about the size of car batteries. So you can imagine to produce the power required to run this spacecraft, you would need multiples in series. Actually, it would be multiples in parallel, technically. This would up the amount of voltage generated and therefore allow more amp hours. So each fuel cell vessel has 3 actual fuel cell reactors in them. A fuel cell is a sort of hydrolysis reactor. So if you input electrolysis to split hydrogen and oxygen, you input electricity to split water, then therefore, if you fuse water together, you have to get electricity out, right? It's just the law of equivalent exchange. So this is a sort of molecular fusion reaction through hydrolysis. Not atomic fusion. This is not sci-fi. This is just a chemical reactor, basically. Here we've got the delta pressure select. We can measure the pressure of H2O and H2O, the difference in pressure. Not entirely sure that this gauge is actually entirely functional at the moment, but it's there. This knob here, white is all the batteries. You've got your C battery, your isolated squib battery. S1 and S2, squib 1, squib 2 for aborting. M for main bus, BT for battery test bus. The black segment, this is all fuel cells. 1A, 1B, 1C, 2A, 2B, 2C. Right? This is the MDIU, the manual data insertion unit. You punch in numbers and it comes out here. This is another clock. Another FDI, and attitude indicator. Again, platform and rate. DCS, Digital Control System. This is like uplink telemetry in Apollo. Here, the auxiliary tape. SEO instruments. I think this is actually supposed to be SEQ for sequence instruments. Again, some things have minor typos. Calibrator, biomedical instrumentation, digital control system power, fuel cell O2 and H2 regulator, heater, horizon scanner heater. Agena is the vehicle, right? So we've got power of the Agena, control of the Agena, and the squibs. This is the rendezvous radar power. This is the attitude control and maneuvering electronics inverter, right? So there are two AC buses. One is IGS for instrument guidance system or inertial guidance system. ACME is attitude control maneuvering electronics. So two buses, right? There are two inverters which power basically just those two things. Your instruments and your attitude control electronics, right? So you can tie in for AC power for some other subsystems that don't really use it much by just changing the switch around. And then they have individual inverters for those main systems that can't be untied from those buses. Here you've got your RCS heaters, tape recorder, power and control, fuel cell 1 and 2 control, and fuel cell delta pressure. Again, attitude indicator, AC, this is alternating current, by the way, AC power, biomedical recorder, RCS heater, and the bus ties. This is the encoder, external lights, the docking index and the EVA bar extender, emergency release, engine arm, and the bus arm. So I believe that is everything to cover here. That's sort of the name of everything. I'm going to make a mark here, and then let's just cover the startup. So let's take everything back off. A little bit of jingle bells there. All right. So here is the Gemini cold and dark startup. Again, first thing you're going to want to do is set your lights up. I like the cabin light on. I like to have this on bright, and the attitude indication lights. All three of these I like on. Next thing, O2 bottle, make sure it's open. And you're going to take all these switches on. Accept time to retro, 256 seconds. Platform rate high. Standby auto. Good. Now for the top panel, it's going to be these switches. All of these will be up. Max flow. And now the radio stuff I can never remember for the life of me. So let's just take a look at that. Here we go. So number 1 here, off. Silence is off. Continuous intercom push to talk. Control on a record. Off command control. So here we go. Calibrator to number 1. Standby transmitter is going to be real time. Transmitter here is going to be real time and acquire. Tape playback is going to be command. Antenna select, reentry, C-band beacon. Good. Off for that. And number 1 switch here is going to be UHF. There we go. Pedestal, radar off. Platform is going to be going to free, so take her all the way to the right. Rate gyros on primary. Computer off, pre-launch, attitude control is going to be on platform. Good. All that closed. Now we get the aux tape on. Platform, rate, and make sure this is high. And now the right panel circuit breakers. That is going to be all of these switches. AC power is going to go to IGS, Biomed 1 and 2, and that finishes that panel off. And fuel cells to warm up. Now, at this point, it's very, very important. You have to pay attention to the timestamps listed here. Right? 10 seconds, your liftoff, all of these have times you need to look at. We're not supposed to do battery check until T minus 50 minutes. T minus 50. So we'll do that at 50 minutes. Here we are at 50 minutes. Let's select the battery testing bus. And let's just check. 24 to 27, good. 24 to 27, 24 to 27, 24 to 27. The testing bus on the batteries is down. Yeah? Back to C. Now at 45 minutes, we'll get our fuel cell check. So let's take her down to 45 minutes, that is. All right. As we take each fuel cell on, again, fuel cells produce DC power, so it should be exactly the same as a battery, right? Fuel cells are just chemical reactor batteries, essentially. So each of the fuel cells is good, and then this section control power ties the fuel cells. But here we could see they're producing, not tied, so it's all volts, and that's good. Take those off and back to C. Squib and abort check at T minus 40. I can't remember. We do start on S1. Yep. So bring her down to T minus 40 minutes, and we'll do our squib and abort check. So for this, take us to S1, off, off, off. You're verifying 0 volts. Umbilical, which is charging the batteries. It's also the squib test bus. Here we can see, look at that. S1 is good. Take these two off, 0 volts, 0 volts. C has voltage, which is good. If we take this one off, C doesn't, so that's good. S2, good volts. And that completes the squib check. Now we can do the request abort and squibs check. We can see the abort light will come on. Good. And then the abort light will turn off. Good. Full internal power at T minus 15 minutes. So let's bring us down to 15 minutes. So this step is the most important to do at the specified time. If you do it before, you use up all of your cryo-react reservoir and you get no fuel cells anymore. And then, hippity-hoppity, your batteries are now Space's property, not yours. So definitely, all right, do this at the designated time. Okay. To start the fuel cells, we are going to need our batteries, though. So here is internal on all batteries. Now we'll enable our fuel cells. They should all be producing volts, yeah? Now we'll tie them to the bus. Here's bus. Fuel cell 1's tied. We can see the 3 A, B, and C amps. And section 2. And here's the amp. So we can see load distribution on the fuel cells. They're automatically throttled. Here's our voltmeter. And this would be the fuel cell ammeter for each fuel cell. A, B, C, A, B, C. Now we can do the pre-flight checks. Yeah? So we come down to 5 minutes, but you're more than welcome to do these pre-flight checks now. Take the computer on, MDIU on. Computer is going to run through its self-checks. Good. Now you're going to take boost insert and retro rocket squibs to arm. Suit fan number 1 and 2. Cooling pump for the primary, pump A, and the secondary, pump A. Radiators will be on bypass. So all this is good. When we take the radiator to flow, we take the evaporator to normal flow. All this is looking good for now. Now the scanner goes to primary, the horizon scanner. Make sure that the D ring or the ejection ring is visible. Good. Now start computer. Platforms are aligning. While that's happening, feel free to just open these in case we abort. once our computer alignment has completed, which it looks like it has, take it to Ascent, but do not run. And now on the MDIU, address 72. And here, pre-launch procedures are complete. Yeah, just getting that portion uploaded. All right, now we go to launching the Gemini. Queue up your Ascent checklist. Take a look at it. We can see abort mode 1 is less than 15,000. Abort mode, the decision abort mode, or abort mode 1-2, is 15 to 75. Abort mode 2 is 75 and up. And abort mode 3 is above that. So at 75,000 feet, we stow the D-ring. And the rest of the abort modes, they happen automatically. But check the end of the Ascent checklist. This is why it's very important to go top down through the procedures in order. All right, take a look. Separate spacecraft, push, jet fairing, push, ohms enable, and look at this, IVI's 0. Okay, now that we have sort of briefed ourselves, let's come down to liftoff. Fuel pumps, the fuel pressurization pumps, they kick in at 30 seconds. So we're looking for red on engine 1 left and 1 right, and then 2 white and liftoff.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition.
There we go. 2 engines running. This is not the way this is supposed to happen, but it's good enough to get the point across. Check our event timer counting up. check the ascent program running, and check the mission timer counting up. Good.
Roger,
Roll should be complete. Good. Now we could check core 72, and we could see we get readouts on this now. Our velocity, our orbital velocity indication. And now it's just pitch program. From here, we just make sure that the attitude rate light doesn't come on. Or just watch the ball.
Mark, 50 seconds, you're looking good, 8.
So here we can see, look at this. We are into more mode 2 now, mode 1-2 that is. So abort mode 1 is done. And at 75,000, which is this dashed mark here, we transfer to abort mode 2. So toggle D-ring. And here we're on abort mode 2 now. From now on, we use this handle to abort and not the ejector seat. So our gravity turn maneuver is almost complete. And just before that completes, we'll be staging. So we can see we're coming up, and here the level sense has armed the staging, so level sense arm. And we have starting to lose thrust, and once that thrust gets inefficient, we begin hot staging the next engine. So we light the second engine before we stage. Here we go.
Roger, staging.
In re-entry, this is not hot staging, but it is in real life. In fact, in real life, the hot staging is quite fantastic. You can actually see flames around the entire capsule. And again, we do get some of those funny re-entry graphics. For whatever reason, Mercury Earth looks pretty good, but the Gemini Earth, again, is very bright for no reason. But now we can see we're at terminal guidance, so we're going to begin pitching and yawing and doing everything. Don't worry about it. Unless, of course, the attitude is obviously very wrong. But you shouldn't need to worry from here on out. And we can see abort mode 2 and 3 are going to happen automatically. We've stowed abort handle, and all is good. A reason for yawing is because we need to insert with the proper inclination in Gemini. Inclination needs to be controlled to insert in such a way that we are lined up with the inclination of the Agena. So this is why it yaws, and not the other two spacecraft. This is called terminal guidance. At this point, we can see this arrow is marked. We are about to cross. Here we go. OAMS to orbit capability. OAMS to orbit capability. At this point, once we hit that dashed line, that level sense is going to be armed. And we're going to start losing thrust and coming to a cutoff point for this Titan. And here is the cutoff right now.
Roger, Seco.
All right. So now, as the checklist says, separate spacecraft, jettison fairing, activate ohms, and zero this out. For us, we luckily just need to do one tap of the L. Now your orbit, now you are officially in orbit, and your ascent is complete at this point. Okay. Just going to hit that pause here. Let me get that one starting to upload. And there we go. Now, orbit insertion checks. Right, orbit insertion checks. So at this point, you should be separated from the spacecraft entirely. Your fairing should be jettisoned. And you should have zeroed out your inertial velocity or your incremental velocity indicator using I, K, J, L, H, or N. Now you can run your insertion checklist, yeah? Come down to insertion. All right, safe the rockets and the boost insert. Now we can do a light test. Good. Good. Now we can come over here, turn off the secondary O2 bottle. Attitude indicator light, circuit breaker, we've already got that. Control lights, center lights as desired. Yep, we've got that. Yes, let's close the water and ohms heaters now. Water tank heater and ohms heaters. All this is already set up. Antenna select can go to adapter now. Cryo quantity off, recorder off. Here we can take the main batteries off and we switch entirely to fuel cell power. And the squib batteries need to be on. AC power should be on IGS bus. Good. Right O2 bottle off. Voltimeter on C. Ohms control power and propellant motor valves. All this closed. Radiator is bypass and computer to catch up. And this is going to take 15-20 minutes to load. this light will be on when the program is loading, and until this light turns off, you cannot run the computer. So now at this point, we can see there's some CO2 building up in the suit loop. You can get rid of it by doing that. We can see it begins to fall, and we can close that now. Now will take us to 30 minutes, and we can see computer has officially loaded the program. You cannot start the computer yet, right? Because you haven't actually done any data insertion for any burns or anything. So this, if you start it now, you'll see throws a malfunction. Yeah. So at this point, let's check out our radiator situation. We can see it's good. So set radiator to flow, evaporator to normal, radiator to flow. And this completes your orbit insertion checks. So at this point, after you've done your checks, all your stuff is loaded in, you may be wondering, oh gee, how do I rendezvous with the target vehicle? Well, it's very simple. Step 1, you need to request a circularization at your periapsis. The Gemini in real life doesn't perform a Hohmann transfer maneuver, but in reentry, it does. And this requires a perfectly circular orbit in order to work efficiently. So let's get our circularization at our periapsis. Click this button.
Roger, DCS.
And now you may be wondering how to translate all of that. Mission tools. Catch-up maneuver pad. You can use a scroll wheel and punch numbers in. So you can see this will translate your ground elapsed time of ignition, your delta V's, burn time, attitude, all that. I don't need it though. So you'll acknowledge the DCS receive with that button and clear the computer. 0, 1. This is the hours and minutes time of ignition. So it should say the first GETI right here, 00111, matches 00111. Good. Clear. 0, 2, readout. 02737. 02737. Good. Clear. Now check 25. 90750. Now this is not 90,000 feet per second. This is actually negative 750. The computer doesn't have a minus, so you can see 9 has a minus above it, signifying that if a 9 is in the first digit, it implies it's a negative number. So that matches. 26 is all zeros, good. And 27. You can see -0, 0, doesn't matter, it's all the same. You can see if you insert -0 manually, you still get 0 in return, right? Now we're up to burn time. There is no computer stuff for the rest of it, so this is just for your own information. The attitude doesn't matter because in reentry, all burns in Gemini are performed impulsively as opposed to like Apollo. So we'll cover that. Our altitude after the burn. And here's the short summary, the brief version. 75.03 feet per second. And our burn time. Now at this point, here we go. Inertial guidance system to sharp end forward. Now we can see our prograde attitude. And we can turn on the ohms, and I can show you what this does, right? If we go rate command, we get manual control of the spacecraft, like so. If we're on sharp end forward and platform, you can see the spacecraft's automatically going to align to 0 pitch and 0 yaw, but notice it does not correct the roll. Needs to be done manually. Now, we just need to perform the burn. I always do this on rate command. And there'll be a reason for this, which we'll talk about closer to the burn. So we'll take a look at our transcript. And here we can see our burn time. So let's approach that 1 hour mark. Here we can see we're close to our burn. So let's start the computer. And you could use the event timer. You could also use, for the computer, it has its own timer for these burns. If we take a look at the memory core, we can see time of ignition is on core 84. And we can see computer is counting down to ignition, but you need to keep spamming readout. It's much easier setting the event than setting the event timer to just look at this and look at the transcript and see 1 hour, 11 minutes, 27 seconds, right? When we get close to the burn, we want to make sure that we're facing really good prograde. We can see we are facing decently good prograde. As we get closer to the burn, we can see the up-down is transferring to forward-backwards. And this is exactly what we want. Now, here we are. Make sure ohms control's on, rate command, computer running, sharp end forward. Sometimes the comp light doesn't come on. It's just a glitch. Here we go. 7, 6, 5, 4, 3, 2, 1, ignition. See? Oh, now the computer is running. And now you cannot burn in any direction or in more than one direction at once. So instead of burning entirely impulsively, I like to use the attitude to sort of stabilize things here. Unfortunately, I was talking about that, so I didn't have time to do it. So we'll just burn impulsively, which is burn all in one direction, then the next, and then the next. And this is impulsive. You burn your forward, backwards, left, right, up, and down. Whereas controlling the attitude with the burn, this is not impulsive. This is a controlled style burn, more like the Apollo program. So that is how you do the first part of orbital insertion. At this point, you reset the computer. And now, of course, CO2 needs to be managed. And now begins the next part. So this will be part 1 of a 3-part demonstration.
DCS.
Damn, I also just realized I had my mic turned off for that entire burn there. That's highly unfortunate. All right. That's okay. Hold on. Content, edit, visibility, private, save. Let's get ourselves back to where we were.
Mark, 50 seconds. You're looking good, 8.
Well, it's very simple. I'm not sure if I trust this configuration. This looks weird to me. We'll just do the launch again. Ooh, that's highly unfortunate. Pre-launch is all right. La, 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 la. Actually, That's good. Let's just take a look at the comms panel configuration. That's what it is. There we go. Let's double check that. Number 1, off, keying, cord, rescue without D, good. And we get number 1, real-time acquire, command, re-entry, off, HF, good. All right. How unfortunate of us to leave our mic off during that second part of the rendezvous, so we're going to have to speed this up here. There we go. Liftoff. How very unfortunate. Oh, we could have been rendezvoused with the Agena by now if I didn't do that. Left my mic off during the second part of the tutorials for rendezvous, so I gotta re-record.
Roger, pitch program.
Scheiße. It's alright, it's alright. We'll do a little speed run. Right, we lost less than 20 minutes, so I'm not upset.
Mark, 50 seconds, you're looking good, 8.
Yeah, we literally lost only probably like 10 minutes of time. We'll hightail it into orbit. Get all that stuff completed again. Here we go, we're on staging. Stand by.
Roger, staging.
Welcome everyone. I apologize, I have to do the ascent over again. I left my mic off for one of the rendezvous tutorial videos, so I have to re-record it. And I figured, why would I'm not gonna go back and do it after the stream because I might forget. So I figured I'd just do the ascent over again. We just finished circularizing the periapsis at that point, so it was only about 10 minutes of lost time, and that does include the ascent, by the way. I definitely can speed run these rendezvous procedures, so this is not a problem at all for me. Okay, OMS to orbital insertion capability is now been achieved. So we are abort mode 3 now. I got that funny tetrahedral Earth render thing again. Reentry has a few graphical inconsistencies at sometimes, but it's great. It's great. Okay, standing by for cutoff very shortly. Terminal guidance has put us in quite a low pitch, but according to our map, we are all right on that. Roger, Seco. Okay. Yeah, look at that. Our IVI is perfectly zero. Fantastic. That is exactly what we like to see. Right, it was that. There we go. And that should be everything. Let's take a look. Insertion. Da, 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 da. Yep. Yep. Yeah, let's do. Good. Antenna select adapter. Yep. Always forget that one. Record off. And see. Okay, looks good. Let's cruise along now. $30 minutes. Looks good. Circularize periapsis.
Roger, DCS.
There we go. All is right with the world. We are exactly where we were before. Almost. Just gotta complete this burn. Which was 1 hours, 11 minutes, 33.71 seconds. Go 33.71, 30, 31, 32, 32.71. There we go. Good burn, good burn. West rendezvous burn.
Roger, DCS.
4558. Good. 3384. 139. 139. 26. 0. 27. 0. Time of ignition. That's all good there. Okay. 45 hours. Christ, of course. It's this bug again. That's okay. We've got the time to do it. We could re-request and see what that brings us, but
Roger, DCS.
yeah, it's always going to be 45 hours. Unfortunate. Well, we'll just roll with the punches, I guess. 45 hours it is. We have plenty of gas for that. Sometimes she likes to glitch out. The Gemini spawns in the wrong location. I find with the cold and dark scenario, it never happens to me, but with the pre-launch scenario that I used, T-minus 10 minute, this always happens. For whatever reason, it spawns in the wrong point in space. This is not a problem. The Gemini, of course, is capable of staying in orbit for, I believe, 2 weeks without any additional cryo tanks. So we'll just time skip that time. It's no problem to me. Yeah, no problem to me. All right, here we go. So, Gemini Rendezvous Part 2, performing the rendezvous transfer burn. Now, I did accidentally mess up the last video, which was perfect, of course, and I had to do the launch over again. I used a pre-launch scenario instead of cold and dark. And in the pre-launch scenario, there is a bug where the Agena spawns in the wrong spot. So this does affect your transfer time. We can see now we're at actually 45 hours. If you do the cold and dark scenario, this is not a bug that happens, but it's also not much to worry about anyways, because the Gemini is capable of staying in orbit for sufficiently longer. As you can see, we've got still 45, or we only went through 20% of our cryo in 45 hours, so it's plenty of time. So now, of course, you would request your rendezvous transfer burn. You get your DCS stuff up, and then you verify. Same thing as before. Cores 1, 2, 25. 25, 26, and 27. Good. And once you are close to the ignition time, which is 58 minutes for us, you can start the computer. So we'll take a computer into start now. '53 or 5844. Here we go. 3, 2, 1. Ignition. So same as before. This time, we're not going to burn impulsively, though. We're going to use our attitude, our pitch, and our yaw to actually self-correct our left and right and our up and down. So this is a non-impulsive burn, and this is because the burn lasts quite a long time, right? So we want to be as accurate with that rendezvous insertion as possible. So here we'll complete the burn. Burn is complete. If we do check our map, we have a very good insertion. At this point, the computer may want to load a second burn, but the tutorial teaches, and I agree, that you use circ app instead. So reset the computer, wipe that out, and at this point, you'll take your rendezvous radar into standby to get that heater turned on. Exterior lights to dock, radar encoder, the Agena radar encoder on, and you'll extend your index for docking. Now, all you need to do is wait to drift towards the target. And that completes the Gemini Part 2 of Rendezvous. There we go, that's better. So, I will copy the old description, upload, rendezvous transfer burn. Here's the description. This goes in the Gus Mobile tutorials. No, not made for kids. Visibility public. And we'll just let that come up. the old video. Can be deleted. There we go. Okay, part 3 of the Gemini rendezvous. This is going to be pretty much the same as part 1. You're going to request a burn, circularization at apoapsis.
Roger, DCS.
So again, here, acknowledge your DCS uplink. 01 should read 04643, so 46 hours, 43 minutes. Put a description for folks who don't know what Gemini is. Yeah, that's a good idea. I thought that they would automatically do the Wikipedia thing, but I'll have to figure out how to do that. Yeah, the Wikipedia thing. I know what you're talking about. I've seen it. I just don't know how to do it. I'll figure that out at some point. Here we go. So 00409. And here's 25, 136, so yep, 01368. 26 is either going to be -0 or 0. That's okay. 27 will be 0, and that's good. So at 46 hours, 43 minutes, we'll do our burn. Again, make sure we're facing prograde. Make sure our ohms are on, showing SEF. Rate command for all the burns because that's just the way to do it. The platform is not meant for accurate burn at all. So we'll come up to the 43-hour mark. 36, 37, 38, 39, 40, 41, 42. Here we go. When you're close, start the computer. And right when you're supposed to start the burn, comp light should turn on. Ignition. Again, make sure to control up, down, left, right with your pitch and your yaw because this is quite a long burn. And we can see burn complete. And we have a pretty decent orbit insertion. So that is going to be complete part 3, and part 4 will perform the rendezvous. Just pumping out these tutorial videos at the same time. Gemini rendezvous part 3. Okay, so after completing the apoapsis circularization burn, go ahead and reset your computer and immediately start loading the rendezvous program. Now get your rendezvous radar on, and we should have a lock. At this point, you can go to radar attitude and center your yellow needles. Once they are centered, you can go ahead and just burn forward to get this counting on the plus side. And since we're more far away than I normally would be due to the bug of the pre-launch scenario, instead of the cold dark, we'll go for it about 100 feet per second. Now we can see we're not quite seeing the Agena at all. So to mitigate this, if we take a look at our Agena commands, here we can see our acquisition light is 251. So we will set the status display to bright. So we'll go 201 like so. And now 2, 5, and 1. And we can see out the window. There's our acquisition light, and we have perfect sighting of the Agena. This is all encoded through the rendezvous radar, so if you have this turned off, the encoder won't work. It modulates the radar signal in order to create the commands for the Agena. As you're coming close to the Agena, you'll notice your needles start to deflect a bit. This is a very simple mitigation. You're going to not point towards the target, but you're actually going to translate. So when the needle deflects up, you translate up. When it deflects right, you translate right. This is done. I is up, K is down, J is left, L is right, H is forward, and N are backwards. Same as we learned in part 1. So you can see we gotta translate up and to the right. Now we can skip time just a little bit. And now we can see we are on the scale change. We are on terminal approach. So now our translation will have a greater effect. And the piece of advice I have for everyone doing rendezvous is don't really care about what's happening out the window, right? Window's not going to help you much. It's all about the instrumentation. Keep your speed under your range needle to ensure you don't crash. As a matter of fact, I usually prefer to approach at 50 feet per second, but we can bring her down to 75 just to get things to speed up a bit. Now that we're slower, our translations will have a bit more of an effect. And hello. That was very interesting. The Agena just glitched out there. There she is. Let's translate forward again. I have no idea why that happened. But the same rules are going to apply. Don't let the range rate needle pass, or don't let the range needle pass the range rate needle. At this point, 50 feet per second is more than enough. Unsure why the Aegina felt the need to teleport across the screen, but that's okay. We will simply just change our rendezvous heading. As you can see, range is coming in, and as long as we keep these yellow needles pretty center, we'll approach the target, right? The window is not exactly going to help you, yeah? It's good for when you're really close, but when you're this far out, the window is just, it's terrible. Just don't use it. The needles, your instruments, they're there for a reason. Right, so bring the needles in. Always, always center then. Couple pulses. Steady out that up and down needle. And then we will steady out the left and right needle. Again, couple pulses. And there we have it. There's that target vehicle. I think it's looking a little bit strange, but we'll see. Here we can see, look at that, range rate. We can't let that range rate fall behind the range. So bring that range rate needle down. And we can see we've got to come left and we've got to come down. Again, don't let that rate needle or the range needle cross your rate needle or you'll crash. So here's the target. And we can see that the Aegina has definitely glitched out for sure. This is one of the stranger glitches I've had. But now that we're this close, it's pretty safe to just translate your way through. Or not translate, to just use the window, that is. Yeah, this is indeed one of the more peculiar bugs I've seen. Let's get that light off. Ah, nope. Okay, she's looking normal. Okay. So then we'll drift around the vehicle. Alright, we're just looking at the engine. She's alright. Just very flickery. So let's spin around. Here we go. Almost there. And there we go. We've come pretty much to a stop, so let's roll around and get into our docking attitude. So you may be wondering, right, there is this cutout and this arm is very clearly supposed to go in there, right? But you may be wondering, like, in 3 dimensions, right? And really this is like 6 degrees of freedom. This is like very hard to see when you're perfectly lined up, right? It's like when you're using those 3D modeling programs. So with this very simple procedure, when the rendezvous tape is loaded into the computer, press start. Here we can see our range on each axis now. And go to computer attitude. Now when you align and center needles, this is the attitude you're going to need in order to dock. It quite literally is that simple. And we can see we need to come down a little bit. So let's burn a little down. And we're steady. And now we just come forward. We can see roll is just a smidgen off, so let's fix that. There we go. And now we're right on the money. You can translate forward. Make sure that your bus arm is on dock, or you won't be able to dock. Just come forward. Use your instrumentation to help you out. You can see it's come just a little bit down. That is a little bit like this. There we go. And just a little down like that. There we go. Slow down as you approach. Come up. A little bit this way. And there you go. Go forwards just a little bit. We fix the roll a slight bit. A little bit of the pitch. It's all about delicate maneuvering. And there we can see we are docked. So make sure to cycle your TDA rigid valve, rigid stop. So rigidize, stop, and off. And now we are docked. Now we can see when we put in any attitude control, we control with the Agena simultaneously with the Gemini. So from this point on, turn off the computer, or reset it, that is, and you're officially docked. Bus arm safe. Dock lights off. And welcome to the club of the very few people to ever perform rendezvous and docking in reentry. Thank you. Alrighty, rendezvous transfer burn is published, and now I just need to upload part 3. This is going to be apoapsis circularization. Okay, no, not made for kids. Visibility, public, details. Yeah, we'll just let that sort of figure out what kind of, what is it called? Cover image it wants to use. That should take just a few more seconds. There we go. Let's use this one. Looks good. Terminal phase approach and docking. All right. What do you guys say we do a burn with the Aegina? Huh? We have this massive and powerful rocket engine attached to the Gemini spacecraft now. I suppose it would only be logical if we used it, right? What do you guys think? I, for one, think we should use it. Let's get those approach lights on for one. There we go. It doesn't really help out. Does this help? Yeah, that helps. Okay, we'll leave that on then. 140. Yeah, I mean, it would only make sense to use this massive rocket engine. Okay, igniting the Aegina rocket engine. So for this, attitude control, we do need to set up. So let's go with the Aegina encoder here. We need to do 361. 3, 1, 0. 3, 2, 1. And now, since we haven't done it before, 4, 0, 1. 3, 0, 1. 3, 5, 1. 3, 4, 1. And let's stabilize out. Here we go. So once we are in the desired attitude, then let's go 3, 5, 0. 3, 5, 0. And now I say let's do this burn. So 5, 7, 1 activates that twirly antenna at the top right here. And now 4, 5, 0 switches the deadband on that to narrow. Gives us a better signal strength. And now engine arm switch to arm. 5, 2, 1 activates the VM, which is, I believe that's vernier management. Here we go. Main engine light on. Armed light on. And now 5, 0, 1 lights the engine. So let's have a look at our orbit data. And ready, 4, 3, 2, 1, ignition. Cut off. And would you look at that? A spectacular ignition by the engine. Now, 4, 5, 1 for switching back to the wide deadband. Engine arm switch off. And 5, 2, 0 disables vernier management. All right. Now it's a simple matter of, well, of course we're gonna have to circularize that out again, but it's a very simple procedure we've just accomplished. And thank you for watching. Glorious. All right. I say let's come around to the light side. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Alrighty. Performing an EVA in Gemini. This is quite simple. Exterior lights to EVA. EVA bars extend. And now you can do your EVA checklist. So pre-EVA. Cryo quantity gauge needs to turn off. O2 and H2 heaters should be in auto. Suit fan number 1 and 2, good. We will close the air recirc. All that's good. Left O2 bottle closed, right O2 bottle open. Both FDAI need to be set to platform and rate. Propellant quantity gauge off. Attitude control to pulse. Radar comes off now. Computer on navigation mode. Voltimeter monitoring the main bus this time, which is 0, yes, because our main batteries aren't on. Let's go with, you know what, I like the red. Let's go with the red on this one. Attitude indicator, all Agena control circuit breakers, good. HF, retract / off for 1 minute. We never deployed the HF antenna, but we'll still do it. UHF, UHF, very good. HF should be off, good. Keying, good. Antenna select adapter. TMs to command. C-band beacons to command. Now we switch pumps. Cabin air recirc down. RCS heater on. Exterior lights apparently need to go to dock instead of EVA. That's all right. Event timer, stop, and 0 it out. And on standby. Have it counting up. Max O2 pressure 800 psi. That's very good. Cabin repress closed. Good. Now we are go for the egress. Record continuous. Air recirc is already down. Shut off ohms control. And vent the cabin. Once the cabin is vented, close the handle and toggle the hatch. And switched orbit rate. Now we are go for the EVA. So for the EVA now, I recommend facing towards the vehicle and just give it a pulse backwards. Just a little pulse. once you're far enough away from the spacecraft that you're not going to hit it, give it a pulse forward. Little pulse till you come to a stop. Come over here. Give us a bigger pulse. Couple milliseconds worth of fuel. Bring her down. Once you are past the Gemini, pulse back. And now just bring her in. There's that EVA backpack. As you can see, this takes just a little bit of skill. Once you're there, left click and bam, now you've got a lot more fuel to work with. We can inspect the Agena here. Fly around. Make sure everything looks nice and good. So we've done our fly around. I'd say that is pretty sufficient for an EVA. Now we just need to approach the hatch. And all is pretty right with the world. And there we go. Now, post EVA procedures. We close the hatch. Close the secondary O2 bottles. Bypass the radiators. Open the repress knob. And let's just get this going a little faster. There we go. Once your repress is complete, close the repress knob. Set flow through the radiators again. Can temporarily open your right O2 bottle and get that cabin air recirc back off. There you go. And now I just recommend running the things you did in pre-EVA sort of in reverse order. So with this one, we do close this right bottle. We turn off the lights, turn off the index bar, and then we can take off the RCS heater. We can get C-band beacon back, TM's back, record off, switch around our cooling pumps again, voltimeter back to C, get our lights back to the way they were. And everything else should be great. You can bring up your cryo levels again. And that will do it. Alrighty. Undocking is easy, I'm sure. Someone could figure that out on their own. There's literally a switch called undock. So I'm sure they'll be alright with that. And there we go. Alright, let's undock. Goodbye, Gina. You cause us so much heartache with your weird flickery textures. Adios. Okay, let's recircularize at periapsis, and it will be...
Roger, DCS.
We will be go for the deorbit. Eight, 7, 6, 5, 4, 3, 2, 1. Ignition. There we go. Now we're in that beautiful orbit. Right. Let's take a look. If we do retro about right here, we will definitely land in the water. Okay, performing Gemini deorbit and reentry. Ensure that your orbital pointer is set to burn at a point where about a quarter of the globe away there is water, right? Definitely going to need ample space. You're going to want to make sure that there is definitely a lot of water where you're going to be landing. Otherwise, you land on land, and that's going to hurt really bad. So we are looking at, we could see we're just about 30 minutes down to retro. So let's just do those pre-retro checks. So sequence lights, they need to be bright. I actually like the sequence light dim because it makes it easier for me to read. I don't know about you guys. But we do need to do the test. And that's good. And now what we need to do is we need to ensure that the computer is actually we'll set it to pre-launch and start, and now we know for sure that it's running and it will receive our retro at orbital cursor. So now we just check core 19 and we do have the countdown. Good. Okay, so once you have that set up, now is the time you turn your time to retro 256-second circuit breaker on. Very important, that one. Blunt end forward. Let's align to blunt end forward. Of which we are already aligned. Look at us. Amazing. So blunt end forward, platform, make sure we're aligned to that. Event timer, we need to set this to 20 minutes. While that's being set, open the left O2 bottle. Overhead panel. Let's open the water and ohms heaters. C-band reentry beacon. Antenna select. Yep, that's all good. Voltimeter, we're going to do a battery test now. Make sure all our batteries are good. Ooh, battery 1 is out. Battery 2 is good. 3 is good. And 4 is out. So we have 2 batteries left. That's yikes. But we'll for sure make it. Now the right panel. We can open the calibrator, Agena power and control. And exterior lights set to off. Engine is stopped. Right O2 bottle open. And now at time to retro, T-minus 20 minutes, we start the clock and get the computer running the reentry program load. We can actually begin running that program now. But of course, if we did that, we wouldn't get the countdown. We do have our own though, but we'll just do it as the checklist says. Make sure we're setting the timer to count down. And we'll bring it forward to 20 minutes. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Clock start. There we go. Now we don't need that anymore. Let's get that computer loading the reentry program. Very vital to our survival. And let's get aligned with our retro, or our blunt end forward attitude. Okay, once that's complete, 256 second to retro checklist. So let's bring her down. Okay, here we are. At 4 minutes, 16 seconds. Lights will turn on. There we go. So once the lights are verified on, verify computer reentry. Good. Squib batteries are on. Main batteries are on. RCS propellant motor on. Monitor system A. Record to continuous. Cryo quantity gauge off. Antenna select reentry. I've already done that. So platform. Attitude. Scale high. Rate command reentry. ohms control, power, and propellant motor valves off. Both RCS control to Acme. And now indicate retro attitude. Activate the RCS. Retro power arm. Now we hold this retro attitude, which is a 20 degrees pitch down. Platform, attitude, scale is high. High frequency transceiver is already off. Our coolant pumps off. Bypass the radiator. And now we start our 1 minute to retro checklist. And we wait for 1 minute. We're just going to refresh ourselves. Good. Okay. So yes, we do need to hold that 20 degrees pitch down. Which is right there. And now we bring her along to 1 minute. We are down 1 minute to retro. Separate OM's line. Separate electrical system. There we go. And staging. And now we can do that pitch up. Bring us back to that retro attitude. T-minus 30 seconds. Retro rocket squibs armed. And here we go. Auto arm. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. So you can see they do request that you do press manual fire retro, even though you have the auto system armed, just in case it doesn't work. Burn is complete. At the 30-second mark, platform is blunt and forward. We've done that. At the 45-second mark, retrojet armed. And staging. And there goes our retro pack. Now we can start retro checklist, or the entry post retro jettison checklist, that is. Retro power and jet, safe. Retro rocket squibs, safe. And now computer attitude, low. Same here. RCS control power B, off. Boost insert, off. Retro sequence, off. Cryo O2 and H2 heaters, off. OMS control propellant circuit breaker off. Fuel cell control 1 and 2 off. Tape recorder control off. And turn off these switches here. Landing squibs armed. And we are go for the landing now. Now we start entry checklist. Time of retro will vary depending on your time of reentry will vary depending on your entry angle. Yep. So 170 degrees roll. And the horizon should be at the top of the window. Here we are. And we are all set for coming in. What do you guys say we take the spacecraft down, huh? I think so. At this point, I like to turn the lights off. I know it may seem a little funny, but trust me, it's a good time. Once we get the warning about atmospheric interface, here we go. Prepare for entry and drag. Let's take a look at our G indicator. Here we can see aerodynamic forces. So now we can see at the 400,000 foot level, after roll needle deflects, spacecraft control attitude to backup bank angle and damp pitch and yaw rates. Here we go. And we are going to secure capture now by going lift vector up. There we go. And now we just basically follow the computer set roll. So what the computer wants us to do is what we'll do. And things will start getting intense very shortly, I promise. Here we go. We can see it's starting. One G. There it is. Two Gs. Three Gs. Four Gs. Five Gs. 6, 7, 8, 9. Don't know why the computer hasn't commanded a pitch or a rollover yet. But for sure, we definitely got to roll out of that. Ooh, come on. That's 1 G to the breakup point. Very close there. Whoop, and we're out. Here we can see 40,000 foot high altitude drogue out. Now let's start our landing checklist. Uncover the D-ring. At 27,000 feet, we are a little past it. We turn the O2 rate high on. And now we wait for main deployment. And as you can see, we're coming down right over the water. Almost at our 10.6 thousand mark. Standing by for main deploy. $10.6. Parachute out. Once we verify good main deployment, we can essentially press this button, which will tug on one of the parachute lines and orient us to our landing attitude. Of course, in reentry, it doesn't simulate the tugging. It just kind of tilts the spacecraft weirdly like that. I know. Very strange and peculiar. But once that is out, attitude indicator circuit breaker is open. Rescue beacon without light. Acme bias power off. RCS heaters are off, and we can take those circuit breakers off too. Scan heater open. Computer pre-launch and off. We'll turn the MDIU off too. Platform off. Rate gyros off. AC power off. RCS circuit breakers, that would be these, are open. RCS squib and RCS. All RCS circuit breakers are open. RCS control off. Acme control number 1 and 2. Open. And at 2,000 feet, we can take the abort handle off, or the ejector seat handle. Now we're just waiting for splashdown. We're chilling like a villain. And if you guys have been on the channel long enough, you know that I don't cop out on the post-landing procedures. A lot of people do. I'm not one to do that though, so we will be doing that as a part of this demonstration. If you don't like that, that is completely up to you. You are more than welcome to, of course, stop the video here, but we'll be doing it. So, post-landing, parachute jet. And let's extend that antenna. Landing squib safe. HFTR to reentry. Number 2 audio to HFDF. There we go. Extending is complete. All radio switches off except for UHF number 1. Number 1 audio switch to UHF. That would be all the switches for radios, except this and this. Left circuit breakers. All circuit breakers open except audio UHF relay circuit breaker. I misinterpreted what that said. Here we go. Tone box closed. HFTR closed. HF whip closed. Second row. All circuit breakers open except for electric timer, indicator light test, and sequence lights control. Third row, all circuit breakers open. All switches on the right switch panel off except biomedical recorders 1 and 2. Main batteries and squib batteries. All right. DC-DC converters on primary. Rescue beacon without light. HFTR switch reentry. Overhead panels. First row, RCS A and B circuit breakers open. Second row, attitude thrusters open. Third row, maneuver thrusters open. Fourth row, Acme, ohms control, and RCS squib open. Fifth row, all open except cabin lights. Sixth row, all open except for the suit fans. Seventh row, all open except for rescue beacons, DC-DC converter. cabin vent down, water seal, and snorkel. 10 minutes after landing. We'll pretend like it's 10 minutes just for the sake of time. DC-DC converter off. Circuit breaker open. Indicator lights test and sequence lights. Normal egress. HF whip antenna circuit breaker open. All switches open except for rescue beacon. And since it's daytime, it's rescue beacon without light. Okay. Power down complete. Thanks for flying.